part 5 of question 3 says, using the matrix method, calculate the values of x and y, for which we have the two equations, pure simultaneous equations, 2x minus y equals 0, x plus 3y equals 7. So with those two equations, we're going to basically do the first step, which is to rewrite the equation in the matrix equation format, which is a times x equals b, where a, x, and b are actually matrices. So let's split this up. Coefficient matrix times the variable matrix x is equal to the constant matrix b. So for the coefficient matrix, we're going to take the coefficients of the equations, okay? So let's do that quickly. So here, the coefficients are basically numbers that multiply variables, okay? So for instance, 2x means what? 2 times x. So that 2 is a coefficient. It's a numerical multiplier of the variable. 2 is multiplying x, and so 2 is our first coefficient. What is multiplying y here? Well, negative 1. Think about it. 1 times y gives us what? Y. If I apply a negative to it, it will be negative y. So negative 1 times y is negative y. So this negative y here is really a negative 1. Think about it a little bit so you can actually figure that out, what goes here. What times x give us x? Well, 1 times x gives us x. So it means that the multiplier of x is actually a 1. And that's the numerical coefficient. What is the multiplier of y here in this case? That's going to be 3. So that's what goes here. So if you look at this, it's 2, negative 1, 1, and 3. Now, what goes for the x matrix? We call that the variable matrix. So we have two variables in the equations, and that's x and y. And for the constant matrix, the numbers that are just there by themselves after the equal sign, 0 and 7. Write them in the order we're seeing them, 0 for top, 7 below. And so that's it for the matrix equation. That's our first step. We rewrite the two equations in the matrix equation form. The next step that we want to do is to remove this matrix here. And so how we do that is to pre-multiply both sides by the inverse of A. Now, how do we write the inverse of A? Okay, so that was done in the previous video, but I'm going to just do it again just for your understanding in case you do not have access to that video right now. All right, so if we want the inverse basically of a matrix, let's have it right here. If I have A being a 2 by 2 matrix with the components A, B, C, and D, to find A inverse, we simply write 1 divided by what we call the determinant of A. And to find the determinant of A, we multiply these two entries here, A times D, minus these two entries here, B times C. It's just rules. And to get good at it, you just have to practice it to know where certain numbers will go, what operations to take. All right, so it's 1 divided by what? We call the what? Determinant. See, so this value that we get below here is what we would call the determinant. I'm going to now multiply this 1 divided by this number. We call this number here a scalar since it can be a fraction, 1 over whatever number this is. Only way it's not a fraction if this number turned out to be a negative 1 or a positive 1. Then it'd be negative 1 or 1. And we call this a scalar. Not what's here, but the 1 divided by whatever value that is. It would be a number. So we call it scalar. Now, this scalar, the 1 divided by the determinant, will multiply by what we call the adjoint matrix. And how do we achieve, or how do we get the adjoint matrix? That's pretty easy. It's just simply changing, switching these numbers, all right? Switching those numbers, you're going to see how that is done. So switch these numbers, A and D. So that means that D goes here and A goes here. What about the other parts, you know, since it's a 2 by 2 matrix? Well, what we do to this guy, we just multiply him by negative 1. What we do to this guy here, we multiply him by negative 1. And so B times negative 1 becomes negative B, and C times negative 1 becomes negative C. So it means whatever numbers we have here and here, we just simply change the signs, okay? And this will all work out to what we call the inverse of A. So why did I do all of this? Big question. Well, we have A here, we have X here, and we have B here. So when we transpose the A, so in other words, let's look at it again. AX equal B is an equation. When I transpose the A to the other side, it becomes the inverse of A. The negative 1 here is just so notation for the inverse of A. When I put back the B, because B is unchanged since it's not transposed from one side to the next. The X is also not transposed, so we leave it as just X. The only thing that has been transposed is the A, and it will take a different form as A inverse on the other side. Okay, play the video. Start from the beginning again to make sure you get all these points down. But let's proceed in the event that you get the concepts so far. Variable matrix equal Remember we said that this is going to go to the other side as A inverse. Remember we say it's going to be 1 divided by the determinant. Remember what we did for the determinant? We basically take these two entries of the leading diagonal and multiply them. Say it's 2 multiplied by 3 minus, and then we're going to do what? Take these two entries of the non-leading diagonal. That's going to be negative 1 times 1. Let's put it in bracket here. Negative 1 times 1. Okay. Well, I wasn't being consistent here. I could have put 2 times 3 in brackets just as I did here. But even with this, it means 2 times 3. So don't get confused with that. And what is 2 times 3? 2 times 3 is actually 6. And what is negative 1 times 1? That's going to be simply negative 1, actually. Let me write about that number. That should be here, which is 3. What we need to do next is to write what we call the adjoint. Remember what we do for the adjoint? We're going to switch these guys. So 3 goes here and 2 goes here. What we're going to do for these guys, we're going to multiply this guy by negative 1. So that's negative 1 times negative 1. Since this number here is already negative 1. Negative 1 times negative 1 is going to be what? The negative and negative is positive, and the 1 times 1 is 1. So it's going to be a 1 here. What's negative 1 times 1? Okay, that's going to be negative 1. Negative 1 times 1, simply negative 1. Now let's simplify this. 6 minus negative 1. Negative, when we subtract a negative, we get what? Positive. So there's going to be a positive 1 here. And what is 6 plus 1? That's 7. Now remember, again, we worked out the inverse. So this is the inverse of A. Is 1 divided by the determinant of A times the adjoint of A. Matrix X with components X and Y is A inverse times B. AX equals B. When we transpose A, it becomes X equals A inverse times B. And so we have our X matrix. We have the equal sign, of course, as we have here. A inverse, which is all of this, 1 over the determinant times the adjoint. Now we need to write the B matrix. Let's write that down. And the B matrix is the matrix with components 0 and 7. We're going to multiply the two matrices. I'm going to leave the fraction for now. So what we're going to do, we're going to multiply rows by column. So we're going to switch this, separate this matrix into rows. So we have row 1, row 2. So row 1 consists of the entries 3 and 1. And we're going to look at the column. When we multiply matrices, we multiply rows by columns, right? By the rows by columns. So for this row 1, we're going to multiply it by this column 1. Remember, 1 row multiplied by 1 column will give us 1 number or entry. So when we multiply this row by this column, we're going to end up with just 1 number. Now, how is that possible when we have 2 numbers here and 2 numbers here? But guess what? We take the first number of the row and multiply it by the first number of the column. So 3 times 0 gets added to the second entry of row 1. We'll multiply the second entry of column 1, entry 1 and entry 2. So entry 1 of this row multiply entry 1 of this column. And so we get 3 times 0 is 0. And the second entry of row 1 will multiply the second entry of column 1. So 1 times 7 is 7. Hope that was clear. All right. And all of this will give us simply 1 number. Now what is 3 times 0? 3 times 0 is 0. What is 1 times 7? Simply 7, right? So that's what we have so far. 1 row by 1 column gave us 1 entry. What's that entry? 0 plus 7, which is... Next, we're going to go to row 2, and row 2 will multiply column 1. It's going to be negative 1 times 0. Let's write it down here. Negative 1 times 0, so you can see what's happening. So we're going to go first entry, multiply the first entry of column 1. So it'll be negative 1 times 0 we have here. I'm going to add that to, this is row 2, second entry. This is row column 1, second entry. So it'll be second entries will multiply. So 2 times 7. Now the reason why we're going to get 1 entry after multiplying 1 row by 1 column is that we're going to add the products. The first entry product by the second entry product. This is going to give us 0, because negative 1 times 0 is 0, plus 2 7s 14. And 0 plus 14 is 14, so we're going to put that here. Well, the next step after this is to write x, y for the column matrix. Now, what is 1/7 of 7? This is instruction that we have left. We can't do anything else within bracket. So we go and we find 1/7 of each entry. 1/7 of 7, put 7 over 1 as a fraction, and then divide by the highest common factor. Now, 7 is the highest common factor of itself. Into itself goes once, itself goes once. 1 times 1 is 1, 1 times 1 is 1, 1 into 1 is 1. And so we do the next part, 1/7 of 14. Put 14 over 1, 1/7. 77 goes once, and 7 into 14 goes twice, which leaves us multiplying the numerators. 1 times 2 is 2, 1 times 1 is 1, and of course 2 over 1, or 2 divided by 1 is 2. And so 1/7 of 7 is simply 1, as we got here. 1/7 of 14 is 2, as we got there. Now we have two matrices that are equal. And what happens if two matrices are equal? Well, the corresponding entries will be equal. Because since they're equal, it's simply saying that x here is the same as this number in that position as x. So x is equal to 1, and y is also equal to the other entry, which is 2. Now we can double check our solution by going back to the original. We're going to take the equations we're given, 2 times some number x, let's use bracket for multiplication there, minus some number y. Now x we're saying here is 1. Let's see. So it's 2 times the x value, so it's 2 times 1, minus the y value that we got, which is 2. Let's put minus 2. 2 times 1 is 2 itself, minus 2, which will give us what? 0. And that's what we have here. That works out. Great. Let's check the next one. X plus 3y equals 7. The x value is 1, so we put a 1 there, plus 3 times the y value. Now what is the y value that we worked out? Y is 2. This actually means here 3 times 2. Of course, it's 1 plus the product of 3 and y. So 1 plus the product of 3 and 2 means 1 plus 6. All right, so that's 1 plus 6, because 3 2s is 6, which gives us 7. And it did work out. So x plus 3y is 7, and that's proven true when we substitute the values of x and y. All right, so this video hopefully did clarify some things that you needed to know. Thank you for watching. Please don't forget to subscribe and be notified of upcoming video, which will be pretty soon, and you don't want to miss those. CXC is coming.